press pause and answer the question.
I love this question. I think it's fantastic. All right. So we have this ship. We have this giant ship, and it has these containers on it. And some of them are empty and some of them are full. And we have two different constraints that determine how much the ship can carry. One is it can only carry a certain number of TEUs of these containers. And the other is it can't weigh too much. So one's kind of a volume limitation and one's a weight limitation. And so the question is, if it can carry up to 20,000 containers or a maximum of 190,000 tons, which of the following systems of inequalities represents this relationship? And the correct answer is this one, is 2.25x plus 24y. Now, x is the number of empty containers, y is the number of full ones. So 2.25x plus 24y is less than or equal to 190,000, and x plus y is less than or equal to 20,000. Let's go ahead and kind of explore this a little more. It's pretty interesting, actually. The containerization revolution that happened in the last 50 years has done an incredible amount to disrupt, and it just has a huge impact on your life, whether you know it or not. I'm sitting in a recording studio. I'm looking around the room. There's probably, wood from Canada, and there's this kind of foam absorptive product from, Lord knows where. Maybe that's from Thailand, and the table I'm leaning on is maybe from China, and the blanket I'm leaning on is maybe from Bangladesh, and so forth. So the clipboard, the computer, it's remarkable. It's remarkable. And this entire global trade kind of system we're under, where we might mine the raw materials in one continent and ship it to another to be manufactured into something, and then it's assembled with other pieces that are manufactured somewhere else, and it may be shipped back to the original continent, and in that continent is where they're going to buy the shoes that were resourced from everywhere in the world. Because until the 1950s, it was crazy, man. If you wanted to load a ship full of stuff, everyone kind of brought their materials down to the dock in whatever container they happen to have. So there may be hides of cattle that are just loose being loaded on a ship by people, and boxes of tissues being loaded by people, and bales of cotton that are kind of barrel-like, and they get rolled onto the ship and so forth. And it was up to the dock workers to figure out how these things should be assembled, or how they should be packed. So it took weeks in port because they had to load each thing up individually by hand. They had to figure out how these things got stacked. And then when it got to the eventual port it needed to get to, dock workers there had to unload everything. So they had to roll off the bales of cotton, and they had to take the stinky hides of the cattle one by one off and so forth and throw them to each other, then figure out where they go on the other end, load them onto trucks. So this was a pretty inefficient system. It had the problem that everything was exposed to rain. It had the problem that everything was exposed to theft. Whiskey was really commonly stolen, right? So someone who was a whiskey producer would produce extra whiskey and put it on the ship, knowing that the dock hands were going to walk away with some of the whiskey. It was kind of part of the friction in the system. So at some point we came up, in the 50s, we came up with this system where we had containers, and these containers are loaded at the factory or at the warehouse. And those containers are locked, and they're protected from rain, and they're protected from theft. And the container is just right on a truck. So what you think of as a tractor trailer, often the trailer part is just a flatbed, and the covered part is just a container. And that container is brought to the dock or to the port, and giant cranes load those containers onto the ships, and the ships take off. So it dramatically reduced the amount of time it takes for a ship to be in port. It dramatically reduced the number of dock workers. A lot of people lost their jobs, but shipping around the world became remarkably cheap, and things that when I was a kid cost a lot of money really are pretty cheap now and almost disposable, sometimes in fact disposable. So it's changed our world. Now, let's go back to the system that we're describing. So we have these maximums. we have a certain amount of room, and we can't fit more than 20,000 of these TEUs, of these containers, onto a ship. So if X is the number of empty containers and Y is the number of full containers, as we were told, then X plus Y, the empty containers plus the full containers, is less than or equal to 20,000, because we are told it can carry up to 20,000. So we feel like it's okay to include up to 20,000. It doesn't say less than, it says up to. And then we're also told that we can take a maximum of 190,000 tons, inclusive of the value 190,000 tons. So we have the empty containers, which the number of those is X, and we're going to multiply X by the weight of the empty containers. It's 2.25 tons. And the full containers, which is Y, and we'll multiply that by 24 tons. We're assuming in this problem that all of the full containers are maxed out at 24 tons. And so we have 24 tons times Y, and we have 2.25 tons times X. And that number is going to be less than or equal to, because we have a maximum, of 190,000 tons. And that's our correct answer.